Exam is just a few weeks away. You don't have enough time to revise Add Maths? Hi, my name is Terry. I've been teaching and writing additional mathematics material for more than 25 years. Over the years, I noticed that many students struggle to go through all the topics just before the exam. So I asked myself, what are the most important concepts and questions that students must know to prepare effectively? That is how Express Notes was created. Express Notes is a condensed revision resource that focuses on key concepts, important questions, and step-by-step solution to help you revise quickly and effectively. Each chapter contains about 20 carefully selected examples, and you can complete the revision in about 1 hour. Without further ado, let's get started.
This is Express Notes function. We start off with, in one lesson, I'm going to explain everything, all the example in one chapter. All right. So let's start off with the very simple stuff, very basic stuff that you've learned before, the graphical representation of function. So function, we can actually represent it three ways, using arrow diagram, using what we call graph, or even order pairs. So the very basic stuff for arrow diagram is that normally the first set is called the domain. The second set is called the codomain. The individual item is called the object. So I don't have to write that, right? You can see here, my domain is this, 1, 2, 3. My codomain is 4, 5, 6, 7. The individual element here, they are called object, or if it's more than one, we say objects. The individual element here, they are called image. Okay, a set of all images is called range. Yeah. Now take note, 7 is not part of your range because 7 doesn't have a corresponding object, right? Okay, we can represent it in the form of order pairs. Order pair is basically like coordinate. We write x followed by y, x followed by y, and so on. Okay, then let's talk about function notation. Okay, notation is just a way of writing. So normally we can use arrow like this, f dot x arrow x plus 3, or we can write fx equals x plus 3. Okay, something like that. So we can represent it in the form of graph. Now, even then, graph, there are two types of graph. There are two types of function, we call it. One is called, if you have a single dot like this, is called a discrete function, right? If they take a sets of value, a range of value, we call it continuous. Like, remember you've learned in this probability distribution, right? We talk about discrete versus continuous. Continuous goes in the range. Discrete takes an individual value. Discrete values are countable. Continuous value are measurable. Okay, so the set of values of x are called domain. The set of values of y are called range. Okay, for continuous, we cannot use single value like this. We cannot say domain is this. We can't write domain like this, or range like this, codomain like this. We have to use inequality. For example, in this case, let's say your domain is from 0 to 3. Then we say our domain is x between 0 to 3. Your range, let's say, is from 3 to 6. Then we say our range, D for domain, R for range. We write y or fx, depending whether the function is fx. Yeah, we write 3 to 6. Okay. Now let's look at one example. Example number 1. So the given diagram shows a linear function f. State the domain and the range. Okay, since this is individual element, that means this is a discrete, right? So when you write your domain, we have to write single value. Like, for example, the first one is 1, 2, 3. As for your range goes like this: 3, 5, 7. Do you include 9? No, because 9 doesn't have a corresponding object. Yeah, 9 is a single value, doesn't have an object, so it's not part of your range. Next, using a function notation, express fx in terms of x. Okay, when we say function notation, there are two ways that we can write f dot x arrow, okay, or we can write f bracket x equals, both the same. Okay, now question, what is the relation between them? Can you see? 1 map to 3, 2 map to 5, 2 map to 5. Anybody got any idea? Okay, we have this one make it a bit difficult, a bit more difficult. You may have to use what we call a simple arithmetic. Okay, I don't want to use the arithmetic progression per se, because in Form 2 you already learned this number pattern. I don't know whether you remember. If you go 3, 5, 7, 9, you're actually increasing by what? By 2, right? So generally, we say Tn equals to Kn plus M. What is K? K is the common increase or reduction. Your K is 2. What is M? M is a term before the first term. The first term is 3. The one before first term is 3 minus 2 equals 1. So your F and Fx is, can I write here? 2x plus 1. 2x plus 1. Now, some people say, I don't want to do that. I do one by one. I do trial and error. I know there's a 1 here, right? So, and I want to get 3. So I put 2 times 1 plus 1. And if I want to go from 2 to 5, I know it's 2 times 2, 4, 4 plus 1. This is 5. F3, it will be 2 times 3, 6. 6 plus 1 gives us 7, right? So we can come up with the induction method, if you like. Fx equals to 2x plus 1. Yeah, but for that, guys, if you want to use arithmetic progression, Tn equals a plus n minus 1d, go ahead. Yeah, no problem. Okay, so there are 4 types of relation. We talk about that relation, in earlier, right? You've learned this before. 1-to-1 means what? Every object has one image. For example, you can see from here, one object, one image, one object, one image, one object, one image. This is 1-to-1. So 1-to-many is when one object has multiple images. One object has multiple images. 1-to-many. Okay. Many-to-one is when you have multiple objects share the same image. For example, A and C, they share the same image X. Okay. Some more, B and D share the same image Y. Many-to-one. And lastly, many-to-many is a combination of 1-to-many and many-to-one. You combine them. This is what we call many-to-many relation. Yeah, it's not difficult. Right? So arrow diagram in a way is easier to see because you can see 1 map to 1, 1, 2 map to 1, and so on. But for graph, right, you need to know it's a little bit different. Okay, so for graph, okay, let's start with the 1-to-1. Okay, a 1-to-1 relation, right? To determine the type of relation. Okay, by the way, I just want you to know another thing. Definition of function. How do you define? Function is a special relation where each object has only one image. That means one x must have one y. So there's a way to actually test this. We call it a vertical line test. Okay, a vertical line test means we draw a line, cut the line downwards. Just cut like that. If you cut one time, it is a function. If you cut 2 times, it's not a function. Why do I say 1 time? If you cut 1 time, right, you get 1x mapped onto 1y. So for example, 1x mapped onto 1y is 1-to-1. 1-to-1 is a function. Now, this one I cut 1 time. Yeah, it's a function, right? Because this x has 1y. So it's still a function, but in this case, it's not 1-to-1. Why? Because I have another x value here that map onto the same y. So it's a multiple x to a single y. It's many-to-one relation, but it's still a function. Let's look at the third one, 1-to-many, right? When you draw a line, cut here, you cut how many times? 2 times. So this x value has multiple y value. Remember, a relation is regarded as a function if every object or every x value has one y value. This one you have multiple y. 1-to-many is not a function. And last one, this one I cut here. Oh, 1x got multiple y. But at the same time, there is another x here that share the same y. So it's a combination of 1-to-many and many-to-one. So that makes it many-to-many. So take note, which one is a function, which one is not? 1-to-1 is a function, right? Many-to-one is a function. Which one is not a function? 1-to-many is not a function. Many-to-many not a function. Okay? Clear? You know what is vertical line test? Cut down. If you cut 1 time, it's a function. If you cut 2 times, it's not a function. Okay? Right. Let's look at this. So we can actually, basically, when we say determine whether it's a function, maybe I should add in determine with a reason. The reason is always the type of relation. You explain what type of relation. We know one-to-one is a function, many-to-one is a function. One-to-many is not a function, many-to-many is not a function. So look at the first one. This one is a one-to-many, right? At the same time, 4 and 2 share the same image. It's also a many-to-one. It's a one-to-many and a many-to-one combined. So we say this is a many-to-many relation, therefore is not a function. Okay, now next, let's cut this across. Cut this way, cut this way, vertical line test. 1x, it has 1y. Okay, so we know this is a function. But maybe we can go one step further. I draw this. I hope you can see there's another x value that share the same y value. So this is a many-to-one relation, right? So therefore, it is this still a function? Yes, a function. Yeah, remember, as long as one object has one image, it is a function. Okay, function g is defined by this, gx equals 4x over x minus 3, where x is not equals to k. So find the value of k. So number one, okay, do you still remember this one? A function becomes undefined when the denominator is 0. Yeah? What's your denominator here? Denominator is x minus 3. We let it be 0. Your x is 3. So in this case, they say x cannot be k, right? So k is 3. Yeah, remember, your denominator can be anything, but it can't be 0. Okay, if you don't believe me, let's put 3 inside. What will I get? 4 times 3 divide 3 minus 3. 4 times 3 is 12. 12 divided by 0, infinity, undefined. So the function becomes undefined when your denominator is 0. In this case, your denominator cannot be 3. Okay, next one. Find the image of 5. Image means your y value. Remember, object is your x value. Image is your y value or your gx value. Image of 5 means your object is 5. You want to find the image. Yeah, 5 minus 3. Very simple. This is 20 divided by 2. Answer is 10. Yeah, pretty basic. Next one. Object that is mapped onto itself. Now, map onto itself means your object is the same as your image. Okay, by right, we can draw an arrow diagram like this. Your object is x. Your image is also x. And your image is gx. And gx is the same as x. So what is my gx? 4x over x minus 3. The result is x. So multiply over 4x equals to x squared minus 3x. Bring the 4x to the right-hand side. Minus 3 minus 4 is minus 7. Here we can take out common factor x. X minus 7 equals 0. So x is either 0 or 7. All right. Okay, what is absolute value? Now, you probably have heard and learned before, right? That absolute value, we are interested in the word, magic word is called magnitude, or we say modulus. All right. So if you have 0, 1, 2, 3, and you want to measure this magnitude, so we call it the modulus of 3. Your answer is 3. Now, if you go on the left-hand side of your number line, this will be negative 3. The magnitude or the modulus of it, it is also 3. All right. So now, because of the modulus, so when we say modulus something equals to 3, your x inside your modulus can take 2 possible answers. Your x can either be negative 3 or a positive 3. Now, I can give you, like, for example, the example I've used here is 2x minus 1 equals to, let's say, I just use another number like 5. When you open up this modulus, the 2x minus 1 inside here can be negative 5. It can also be positive 5. You just bring it over. This is negative 4. Divide by 2, you get negative 2. You bring this over. This is 6. X is just 3. Yeah, 2 possibility. All right. Yeah, you remember? Idea of modulus. Pretty simple. Let's look at one example. Example number 4. So here we are substituting, we're finding H3. Your function hx is given. H3 simply means putting 3 inside your x. Your x is your object is 3. You're finding the image of 3. So this is 6, 2 times 3 is 6. 6 minus 7 is -1. Modulus of -1 is just 1. Okay, next. Find the value of x if hx is now 5. So your hx is modulus of 2x minus 7. And this is now 5. So every time you open up a modulus, remember there is a negative and a positive. Sorry, I think I gave you an example very similar just now. This is 5 also, right? But that's -7. -1. This is -7. Bring over. This is 2. X is 1. For the second one, when I bring over, this should be 12. X should be 6. Okay. Before you sketch a graph, I just explain to you briefly the modulus graph, because most of you already know modulus can be a V shape or upside down V. Okay. Most of the time we draw V shape, but because a V shape graph, because normally if this is y equals to x, right? The moment you modulus, you only take the positive value. So whichever part of the graph that falls below, right, is now flip up. It becomes positive. So generally it has a V shape graph. But the moment the number in front here, for example, as you see, you notice I put a K here. The K here, for example, you may have a -2 modulus x. Right? If you have a negative in front, then the graph is upside down. Okay? And generally, the number in front also determines the degree of steepness. So, for example, what is the difference between modulus x, V shape, versus modulus of 2 of modulus x? So 2 is sharper, right? Let's say another one, half is broader. Okay, so you can use Desmos graphing calculator. I think I showed you before, right? You can use Desmos graphing calculator, key in the function, and then you can see it. Yeah, but when you draw the graph, right, unless you draw on the same axis, if you draw on separate axes, you can't tell the difference. They all look the same, right? The steepness can't really be seen. Okay, the next one is the horizontal translation. For example, you're aware of this, right? If I give you 2x minus 3, you let this equals to 0. It's similar to quadratic. You know, quadratic, we have like y equals to 2x minus 3 squared, maybe a plus 5 here. The one inside the bracket, we let it be 0. You get x equals 3 over 2. In quadratic, we call it what? 3 words. What is that? Axis of symmetry, isn't it? Like, for example, this graph, right? It will cut at 3 over 2, and this is your axis symmetry. But in models, we never really draw the dotted line and call it axis symmetry. But just so you know, this represents your x-intercept. Yeah, it's a V shape, or it can be upside down V. But for SPM, somehow they don't test upside down V. Yeah, maybe this year they say, I want to make it K-but, I will give you an upside down V, then more than half the student cannot do because they never seen before, right? Yeah, modulus graph, usually they only deal with a normal V shape. Either you shift left or shift right. Shifting up and upside down, very, very rare. Okay, so the shifting up is this one. What if the number outside is C? It can be positive or negative. For example, classic example, modulus x plus 3. That means I take the V-shaped graph, I shift up by 3, it cuts at 3. A modulus x minus 3. That means I take this V-shaped graph, I shift it down by 3. But like I say, normally they don't test you this in SPM. Okay. Now, let's look at one example. Since this is a sample exam question that they asked before in SPM, all right. So in my express notes, I don't put the clone here idea. That's my normal notes. I just put what is important. Yes, I don't put the clone we share anymore. Okay, so this is the graph of modulus for x plus 5 for the domain of x between -3 to 2. You're supposed to find the value unknown p and q. Okay, p is your x value when your y value is 0. We can just substitute p0. That means my fx, my y, is now 0. My x is now pu plus 5. Okay, now remember, when you open up a modulus, you always have to put a plus minus, but 0 is a neutral number. So what is plus minus 0? It's still 0, right? So your p is -5 over 4. Okay, how about q? Q is your y value when your x value is 2. So we just substitute 2, and q, right? My y is q when my x is 2. So this is 8 plus 5, which is 13. Modulus of 13 is still 13. Q is 13, right? Okay, so that means that this one is 13 here. This one is minus 3. This one is 7. Okay, and this is 2. Okay, the next one. Normally, they will tell you for the given domain, find the range. You see, the domain is already given. This is a domain, right? If I ask you what's the range, then your range is from 0 to 13. But in this case, you're finding the domain that correspond to this range. That means your range is now from 0 to 7. 0 to 7. What is your domain? Okay, we know that we need to find this value. This one don't need to calculate because we already have it, right? So let us take fx, let it be 7. My fx is modulus of 4x plus 5, and this is 7. So every time you open up a modulus, remember to put a plus minus, right? There is a negative 7 and there is a positive 7. So bring this over, minus 7 minus 5, minus 12, x equals minus 3. Positive 7 minus 5, you get 2, x equals to 1 over 2. Now, take note, actually, negative 3, we already have it here. So don't bother about negative 3, we already have it here, we know. So it's just that this one is now what? What is this now? This is now half. And what are we finding? We are finding the domain. Domain is your x value. So we say our domain D is between negative 3 and positive half. Right? So the domain that corresponds to this range is negative 3 to half. So here we're drawing a modulus 7 minus 3x. Okay, so for me, I will always use a table of values. Okay, so I would start off with the smallest x value, which is minus 2, the largest x value, which is 5. Okay, then I'll put x equals 0 and y 0, because this x equals 0 represent your y-intercept. Your y equals 0 represent your x-intercept. Okay, can we substitute inside? Yeah. Like some people, they say, oh, Terry, I want to use calculator. Can actually, yeah. This is the last resort. If you really cannot, you really know, you don't know how to build a table of values, then you can use your calculator. Okay, let me reset this first. 9, this is 3. Okay, so let's say you can use manual 9. 9 for table. I can see it's here. 9 for table, right? You can key in a function. This modulus is under ABS. Shift. Wow, I'm going blind. Where's ABS? This one. ABS stands for absolute. You can't see my calculator. Oh, sorry. Sorry, I forgot to share my calculator. Okay, sorry guys, I didn't realize. Look at this again. You go to menu, 9 for table, shift, open bracket. This ABS. ABS stands for absolute value. 7 minus 3x. X is this. So then you press equals, gx, don't bother, press equals. Where do you start? You start from minus 2, you end with 5. This is 5, exactly 5. Step is always 1, then you press equals. So the problem with doing this is that, in the past, I have students who plot 1 by 1. Then they plot, they will get dot, 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 dot. You won't probably, then they draw like this, Because you cannot see, right? You just thought you just connect the points. That's not the case, because the calculator doesn't show us the x-intercept. Because at x-axis, your y is 0, your x may not be an integer. All these are integer value. This is 13, right? Okay, I'll just take the largest, 13. Your smallest is what? The next one is what? 5 is 8, right? So this is 13, this is 8. X equals 0, we can find. X equals 0 can see from the table is what? From the table is 7, right? This is 7. Y equals 0, you cannot find. So meaning, this, let's say this is -2. Okay, maybe I put -2 a bit closer here. 5 is here. The largest is 13. You can put a dot across if you like. This is 8, a little bit higher here. Then you have, okay, for me, right, I don't want you guys to plot all the points because some people will plot like that, then they find, wow, very hard to connect the lines, right? So you just take the first and the last will do. Don't forget about the rest. This one, by right, it should be going down like this. It's supposed to be going down all the way. One more time. It's supposed to go down all the way like this. Okay, but we don't draw all the way down. Why? Because of the modulus. The moment in modulus, this is reflected up. So this part goes up. You don't draw the negative side anymore. So this one you just draw, extend, erase this. Sorry, my line not very straight. Oops. This will be 7. This will be 8. If you want to draw a dotted line, go ahead. It goes all the way down like this. This is 13. This one down, -2. My graph is almost done, but I still need to find my x-intercept. Well, x-intercept is not very difficult to do. We know at y-axis, x is your x-axis, sorry, your y is 0. When you open up the modulus, your x should be what? 7 equals to 3x. X is 7/3. This is 7/3. Okay, so the table value is not a must. It's just a guideline, easier for us to map and draw. Okay, so my graph is done. One more thing, I'm supposed to state the corresponding range. You see, this -2 to 5 is your domain, right? So this is your domain. Domain represent my x value. Range represent my y value. So my range is from 0 to 13. You can write fx, you can write y. In this case, it's y, not fx, right? Because it's not written as function fx. Yeah, so it's just y. So in this case, we want to find the unknown p, all right? And later on q here. So for p, right, you need to use the set of x and y value given here. So your x value is 2, your y value is 3. We say when x is -2, not 2, your y is 3. Let us sub inside -2 plus p/3, p/-2. Sorry, this -2, your x is -2. The result is 3. So bring this over. This will be p/-2 equals to 5. P is negative. I keep writing the wrong thing. Sorry, -2. P equals to -10. Okay. So now that I know P is -10, right? I need to find my Q value. My Q is my Y value when my X is 4. So let's put 4 inside. Q is my Y value when my X is 4. Let's put 4 inside. 4 minus 10/4. So 4 minus 5/2. 10/4 is 5/2. So this will be 8 minus 5, 3/2. Okay. In the event that you have two unknown in your equation, we have to form two equations and solve them simultaneously. The first one, if I put -1 inside, I get 5. So a times -1 squared plus b times -1 equals to 5. -1 squared is 1, so it's 1a. b times -1 is minus b. The result is 5. Equation 1. Okay, my second one, if I put 3 inside, I get 9. So a times 3 squared plus b times 3. The result is 9. So can we divide by 3? If you divide by 3, you get 9a plus b equals to 3. Equation number 2. So how do you solve it? I'll take 3a. Did I make a mistake here? Okay, divide by 3. Sorry, it's not 9a. Thank you. 9 divided by 3 is 3. So let's take equation 1 plus equation 2. When you add together, 1a plus 3a is 4a, minus b plus b disappear. 5 plus 3 is 8. A is just 2. Okay, you can just sub inside any equation. Here I sub inside equation 1, 2 minus b equals to 5. B is 2 minus 5, negative 3. Okay?
If you find this video helpful and want to improve your Add Maths, you can get my Express Notes and other Add Maths book from Shopee or Lazada. Just search for Teliti. If you prefer a more structured learning approach, you can also enroll in my e-learning course where I'll guide you step by step through the full syllabus. And if you're looking for more personalized guidance, you're welcome to join my tuition classes at Tuition Teliti. Remember to like, subscribe, and share this video with your friends who need help in Add Maths. See you in the next video.